All right, thank you for joining us today. And in this video, we are going to work some examples on product rule and quotient rule and some funny questions, right? So what I'm going to do is, I'm going to go through product rule and then quotient rule before we start the discussion, right? So let me talk about product rule. So with product rule, what we are trying to say is, let's assume that we have f of x, which is equal to, let's say, ab, right? Then with the product rule, when we pick a, then we need to look for a prime. When we pick b, we need to look for what? B prime. So what we are going to do is, now f prime of x will be equal to, we are going to do cross multiplication. So this will multiply this, and this is also going to multiply this. Let me use different color, green. So that's what you are going to do. That's what you are going to get. But don't forget, with product rule, it goes with what? Summation. So it goes with the addition sign here. So I'm going to have a b prime plus b a prime, right? So I multiply a to b prime, then I multiply b to what? A prime. One thing that you need to know from product rule is, because of the addition, this is what? Symmetric. You can decide to bring this one here and decide to bring this one here. It's the same thing, right? So that's what you are going to get. Somebody too can decide that, let f of x to be equal to gen of x, h of x. It's also the same thing. I need to pick my f of x and then differentiate it, which will give me gen prime of x. Then I pick my h of x, differentiate it, which will give me h prime of x, right? So f prime of x will be equal to, so the same thing, multiply this and also multiply this. So we are going to have something like this, gen h prime plus h gen prime. So it's the same thing. No matter the variable that you are going to use, it's going to be the same, right? Okay, so that is the product rule. So I'll just pick, I will just make sure that I'll make this one very small so that I can talk about the quotient rule, so that we can use them together, right? So that we can use them together. So let me talk about the quotient rule. Let me go down and talk about quotient rule. So with the quotient rule, it's very simple also, but we have some things that you need to learn from the quotient rule. So from the quotient rule, let's assume that I have f of x, which is equal to u divided by v, right? So this is the quotient rule. Then the same thing, I need my u, and then I need my u prime, right? Then I need my v, and then I need my v prime. Don't forget, u, if we are using this one, u is up and v is down, right? The v is down. So the v is down, u is on the top. So what is f prime of x? F prime of x is going to be maintain the one at the down, which is v here. So v, then differentiate the top, which is u prime here, u prime, minus, now I maintain the top and then differentiate the down, all divided by the down squared. Now one thing that you need to learn from here is that, because of the negative, the top is not what? Symmetric. It's kind of skewed, right? So if you bring this one like this one first and you bring this one here, let's assume that we are working on this one and we are getting something like -2, you are going to get 2, because you are just turning this one here, putting this one also here, right? So that is the idea. So here, unlike the product rule, because of the summation, you can just bring this one here or this one here, which is going to be the same thing. So here, pay attention here with the one that counts first. So first, we maintain the denominator. We don't differentiate, just write what is on the denominator, and then you differentiate the top minus, now you maintain the top and differentiate the down, all divided by the down squared, right? Let's assume that you do yours like this. Let's assume that this one, instead of using v over f, sorry, u over v, you are using f of s is equal to, let's say, gen over h, right? It's the same thing, gen gen prime h prime. So what are you going to get? I'm going to have something like this. F prime of x will be equal to maintain the denominator, which is h, differentiate the top, gen prime minus. Now I maintain the gen and differentiate the denominator, all divided by denominator squared. So no matter the variable that you are going to use, you are going to get the same thing. But for me, my videos that I'm doing, I'll be using, for the product rule, I'll be using A and B, and then for the quotient rule, I'll be using what? U and what? Vin, right? So this is some tip that you need to learn before we start. So I'll clean up some of this one, then we take it from there. So now let's go to the examples. So now what you are going to do here is, now because we know that product rule is of the form A and B, then I'll make sure I will equate this one to A, B, right? So it means I have two functions here. So one of them will be A, one of them will be B, right? Here the choice of A and B does not depend on anything. Like we don't depend on the choice. Like you don't need to do anything about the choice. You can choose this one to be A, you can choose this one to be B. Is the same thing, right? It does not depend on anything. So what I'm going to do here is, now my A is x squared and my B is e to the power 3x. So from what we just learned, we need A prime, we need B prime. So what is A prime? When I differentiate x squared, I get 2x. When I differentiate e to the power x, since this one is linear, I will just drop the 3 and then maintain the function, right? But in other context, like if I want to explain it in other words, then for me to differentiate this, what I'm going to do is I will differentiate the top, right? When I differentiate 3x, I'll just get 3, then I'll use to multiply what is here. So that's what I'm going to get. Now, what I need to do is, now what is my y prime? Y prime will be equal to, so from you, if you are now starting out learning how to do derivatives or using the power rule, then now you will need this formula here. So now you know A, you know B prime. So A is here, B prime, this one's supposed to be B prime. B prime is here, plus B and then A prime. So B and then A prime here. So kind of doing cross multiplication here, right? So this one is going to give us, so x squared times 3e to the power 3x plus then e to the power 3x times 2x. So this is what you're going to get. Very simple. Now, this one, when you become so good at it, it's very simple. You can just watch the equation and just be doing it, which I will show you right now. So now, this one will be, when I multiply, I'll have 3x squared e to the power 3x plus, when I multiply this and this, when I was marking some of the script, I saw that some of you, when you are doing multiplication with this and this, you like to multiply this to what is here. No, this is an exponential function. This is just multiplying the whole function, not only the one top here, right? So it's like you having 2 to the power 3x times, let's say, 3. So this 3 here is multiplying the whole function, not just the top. So that is one thing that you need to take note. So this one, when I multiply, I have 2x e to the power 3x. So this is what I'm going to get for the product rule, right? So let's look at something. This one, if I know how to do it very well, like I'll just write y prime will be equal to, so I'm just talking about this one. So I maintain one of the function x squared. So first I maintain x squared, then I'll differentiate the other function. So since I'm maintaining x squared, just differentiate the other one, which will be times 3e to the power 3x plus, now don't forget we maintain x squared and we differentiated e to the power 3. The next one should be maintain the one that you differentiated, which is e to the power 3, and then now differentiate the one that you maintain. So I'll maintain e to the power 3x and then differentiate 2x, which is the same as what we have here, the same thing here. Do you see that? So if you are now learning how to do derivative, I would advise you to always go in with, and sometimes some of the functions are very complicated for you to just look at it and do it this way. So even whether you know how to do it or not, it's good for you to learn how to do it by going through this, because sometimes you can just be doing it in your mind and then you just get some things you get them incorrect, like you make some small mistakes, right? So that is the product rule. Let's look at the quotient rule that we just learned. So as I said, I will let this one to be equal to u divided by v, right? So if it is u divided by v, then u will be equal to what? X squared minus 1, and then your v will be equal to 5x plus 2. So don't forget, if u is on the top and v is on the down, you know how to go through the process. So now, since I know my u and then I know my v, what I need to do is I need u prime. So when I differentiate this, what am I going to get? When I differentiate x squared, I'll get 2x. But when I differentiate 1, I'll get 0. So minus 0 is just 2x. What is v prime? When I differentiate 5x, don't forget this 5 here is a constant multiplying x. So this is a constant multiple. So I don't need the 5. Just maintain the 5 here and differentiate the variable here. When I differentiate x, I'll get 1, right? And then when I differentiate 2, I'll get 0. So it means that this is supposed to give us 5, right? So now if we are using the formula that we just derived, so let's assume that you are now learning how to do it, then you'll be like, you need this formula beside you so that you can know the input. Now when you become very good at it, then after you've done this, the one that comes first followed by good. So the y prime will be equal to, now we need vn. So what is vn? Vn is here. So I write 5x plus 2. Now you see this one, because of the addition here, which is separating the 5x and then the 2, because of that, I need to put this one into parentheses. Good. Then the next one too, I'll put it into what? Parentheses. So times, what is u prime? U prime is 2x. So I have 2x minus. So that's one thing about the quotient rule. It's supposed to be minus. So minus. Now I need u. U is s squared minus 1. So s squared minus 1, put it in what? Parentheses. So as I'm doing some of the videos, I've been telling you that your parentheses in mathematics, parentheses are very important when you're dealing with multiplication of minus and functions together. They are very important. Then I'll put this one into parentheses. I need vn prime. What is vn prime? Vn prime is 5. So I'll just have 5 like this, all divided by u squared. What is u? U is here. So I'm going to have 5x plus 2 all squared. So let me try and simplify this and let's see what you're going to get. Y prime will be equal to, now when I multiply, I distribute this and this. 2x times 5x will be 10x squared plus 2x times 2 will be 4x. Then this 5 here will multiply x squared, multiply by minus. So I'm going to have, or I can make it minus. Then this 5 here will multiply this, giving us 5x squared. Then this will multiply this, also giving us minus 5 divided by 5 plus 2 all squared. I don't want to even bother myself simplifying the denominator. So I'll get something like, so this one is going to give us 10x squared plus 4x. Then I'll multiply through the minus, which is going to give us minus 5x squared plus 5 divided by 5x plus 2 all squared. So what will be y prime? I have s squared here, I have s squared here. When I subtract, I will have 5x squared, right? Then this and okay, I think okay, so I'm going to have, so I cannot cancel that, so to be 4x plus 5. Then this one will be 5x plus 2 all squared. So with this one, when I differentiate, this is what I'm going to get. So you see the way we did it step by step. My u, my vn, u prime, vn prime, then I was using this formula right here. But if you are very good and you get used to it, you will see that after you've gotten u prime, v prime, then what you need to remember is you maintain the v, that is the down one, times the derivative of the top, which is also here, then minus, now maintain the top and differentiate the down, then all divided by the down squared, which is going to give us this. Good, 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 good. So now let me clean up the solution here, clean this one too, and then send this one there for the solution for this one. Good. So let's look at C. C2, we are going to use the product rule, right? Because we have two functions. So the same idea, I have a, b. So my a will be equal to 3x plus 1. My b will be equal to 5x minus 4. What is a prime? When I differentiate 3x, I will have 3. But when I differentiate 1, I'll get 0. So that one is done. When I differentiate 5x, I'll have 5. When I differentiate minus 4, it will be 0. So that is what I'm going to get. So the product rule says that we just need to multiply this and that. So b times this, a times that. So a times that. So this times this is going to give us 5, 3x plus 1 plus 3, 5x minus. So you see, this one, when you become very good, the idea was here, what I did was I maintained this, which is right here, then I differentiated this, which is giving 5, then plus, now I need to differentiate the one I maintained, which is 3x plus 1, which is going to give us 3. Then now I'll maintain the one that I differentiated here to get the 5. So if I want to simplify, this one is going to give us 15x plus 5 plus 15x minus 12. So we should get something like 30x minus 7. Yes. So that should be the result for the C. That should be the result for the C. Now let's look at another one here. So this one, you see the way I'm going to do it quick. Look at this. Now here, if I'm not using the rule, like I'm not writing down u vin because I'm very good, I know how to do it. This is how I'm going to do it. I know that the formula is saying that maintain. So this is u divided by vin. So I know that this is vin, this is u. So maintain the denominator or the down, which is x to the power minus x to the power 3 minus 1. Then differentiate the top, right? So I know that differentiate the top. So 3 plus 1 prime. So I use this prime, meaning that I'm come to differentiate what is there. Then minus. Then now I maintain the one with the prime here. So I'm going to write this one again, right? So denominator first, then followed by this, but the prime will be here. Then I'm going to write the same thing again, but I'm going to put the prime here and remove this prime here. So I'm going to have something like 3x to the power 3 minus 1, then x to the power 3 plus 1, but I'll put the prime here. So look at this. You see that like I'm writing the one here, but the idea is that denominator comes first. So the down times the top minus down times the top, right? Always I want to bring the down first because of this one. So down times the top, down times the top. But don't forget here, always the derivative is on the second one, which is the top. Then when you cross the minus and we come here, now the derivative will be on the down. Then all divided by the down squared. Good. So now let's go. Y prime will be equal to 3x to the power 3 minus 1. Then when I differentiate this, what are we going to get? 3x squared minus x to the power. So now I need to differentiate this. What am I going to get? I'm going to have 3x squared, then I'll maintain 3 plus 1, all divided by x to the power 3 minus 1 squared. Right. So this is what I'm going to get. If I want to simplify, then I'll multiply this one by this. We are going to have 3x to the power 5, then multiply this one by this. which is going to give us minus 3x squared, right? So let me make this one too small so that we can continue the work. I hope you can see. Then now I'm going to multiply this to this. So this times minus. So there is minus here, don't forget. So this times the minus, which is going to give us minus 3x to the power 5. Then this times this, but there is another minus also here again. So this one will be minus 3x squared divided by x to the power 3 minus 1 squared. And then this will cancel this. So we are going to have minus 6x squared divided by x to the power 3 minus 1 squared. So this is what you are going to get, right? But if we are not good to go through this, then what I'm going to recommend is now you go through the process as the way we do it, right? I think I cleaned the formula. The way we do it. So you are now doing it. So you will need the formula here, then you need this idea also here. So I know u to be equal to x to the power 3 plus 1, right? And v to be equal to x to the power 3 minus 1. Now what I'm going to do is I need u prime, which is going to be 3x squared, and then v prime, which is going to be 3x squared. Then since I need this formula right here, I know v or v u prime minus u v prime v squared. So y prime will be equal to, what are we going to get? V first, so x to the power 3 times u prime, which is equal to 3x squared, minus, now we need u, so what is u? X to the power 3 minus 1. Then we need v prime, which is also here, 3x squared, all divided by s cubed minus 1 all squared. So we've done the simplification already, and we had something like minus 6x squared divided by s cubed minus 1 squared. So this is what you are going to get at the end of the day, right? So now let's look at the next question here. We have question here. Now to explain why we cannot use the power rule alone to differentiate this. Okay, so the reason is that, when we started the power rule, I made mention of power rule is like if you have f of x is equal to x to the power n, right? And then the power rule says that f prime of x will be equal to n minus 1, right? So n drops down, you maintain the function, then you subtract 1. So this is the power rule. Now we can see that if I write this one in parentheses, this one will be like x to the power n. And you see that this one we have just one coordinate here standing alone, right? Like it's x and the coefficient of x2 is what? 1. When you compare this one is even having another extra term, which is minus 3. And even the coefficient of x is also not 1, it's 2. So it means that we cannot use the power rule because this is not in the form of f of s is equal to, or y is equal to x to the power n. So that's what we can say from there. Now the next question is, then use the product rule to differentiate. So we said the product rule, we need to have function y should be equal to ab, but you can see that this is like just one function, but we can do something about it. Yes. So what we can do about this, what can we do about this? Y will be equal to, now this minus 3 squared is the same as 2x minus 3, 2x minus 3. Good. So now we can see that this is the same as a, b. We have two functions, right? Then we follow the procedure, right? So this one, if you know how to do it, you can go through straight, but I will recommend doing this will help you to differentiate all the functions. So I like picking my a, picking my b, then I find my a prime, which will be 2. I find my b prime, which is also going to be 2. Then y prime will be equal to, so this one, this times that. So this times this, I'm going to have 2 times 2x minus 3 plus 2 times 2x minus 3. So I said product rule is symmetric, right? So you can either multiply this by this first, followed by this second, or this and this first, and this by this in the next, right? Because it's symmetric. You cannot do that with what? Quotient rule. So when I simplify, I'll have 4x minus 6 plus 4x minus 6. So I should have something like 8x minus 12. So that's what you are going to get for the product rule. So as I said, we are doing product rule and quotient rule. We know that we can use the change rule to do this, which our next video we are going to talk about change rule, which we will know how to use the change rule to solve this instead of going through this process. Now let's look at 3. So 3, we have this information here on this table, and then the question is, let's assume that h of x is the same as gen of x, f of x. We need this. So as soon as I see h of x is equal to f of x, gen of x, you see this one is like a and b. So like product rule, right? So for me to find h prime of 0, first I need h prime of x. Before now I can do it. So h of x is equal to f of x, gen of x, which is the same as ab, right? So my a is equal to f of x, my b is equal to gen of x. So a prime will be equal to f prime of x, my b prime will be equal to gen prime of x, right? So what's the product rule? Okay, f prime of x will be equal to, then I just do cross multiplication, any of them, because it's symmetric. So I'm going to have f of x, gen prime of x, plus gen of x, f prime of x. So this is what I'm going to get. So this times this, and this also times that. Now that I have h prime of x to be equal to this, now the question is asking us to evaluate it at when x is equal to 0. So now we can plug in 0. So everything goes 0, 0, 0, 0. So what are we going to do now? Now we are going to make use of the table. Now f, so we have the f and f prime, gen and gen prime. So f at when s is equal to 0. So this is f and this is the x values. So this is 0. So f of 0 will be 5, right? So that is where the 0 and f of x intercept. So we are going to get 5. So this is going to be 5 times, what is gen prime of 0? This is gen prime of 0, negative 3. So we can plug negative 3 there, plus. So you see, it's very simple. What is gen of 0? This is 0 where they intercept 9. So we are going to have 9. Then we need f prime of 0. This is f, this is 0 where they meet, it's 9. So you're going to have 9 here. So this is going to be minus 15 plus 81, and this one should give us something like 6. I think so. Yes, we are going to get 66. So this will be the h prime of 0. This will be the h prime of 0. Good. So you see how I did it? First, I use the product rule to find h prime of x, plug in 0, then I use a table. Now let's look at the b here. This b is like similar to this, but this one was product rule and this is the what? The quotient rule. Always go through the quotient rule, right? So here too, I need to work for k prime of x before now I can look for k prime of 2. So this is equal to u over what? Vn. So it means that u is equal to 1, vn is equal to f of x. What is u prime? When I differentiate a constant, I get 0, right? Then what is vn prime? Vn prime is f prime of x. So let's go through the process. How do you differentiate a function when it is in the quotient form? He said maintain vn, right? So the formula is vn u prime minus u vn prime divided by vn squared. So this is the formula right here. So what is vn? Vin is f of x. What is u prime? U prime is 0 minus what is u? U is 1. What is f prime? Vin prime f prime of x, all divided by f of x squared. That is the Vin squared. So Vin is f of x. We get something like that. You simplify, and 0 times this will just go to 0. Minus 1 times this will just give us minus f prime of x divided by f of x all squared. So this is what you are going to get at the end of the day, right? It's very simple. So just relax, pick your u Vin, go through the process, remember the formulas, and then use them. So now k prime of x is equal to minus f prime of x divided by f of x all squared. Now we need it at k is equal to what? 2, or x is equal to 2. So k prime of 2 will be equal to minus f prime of 2 divided by f of 2 all squared. Right. So now this here, right? This that we have here. Now we go to the table, then we look for f prime of 2. This is f prime. Where is 2? 2 is here. So this is where they are going to meet. So that one will be 3. So this one is going to be minus 3 divided by, we need to go and look for f of 2. This is f, this is 2. So we are going to get negative 5. So we are going to have negative 5 squared. Then when I simplify, I'm going to have minus 3 divided by 25. So this is how you need to go through the process, right? So when the question is given to you, relax, okay? Relax and then look at what you need to do before you start, right? So that will be the question 3. Let's look at the fun aspect. So we want to, do some simplification, kind of, bonus question with like small algebra, right? We want to make sure we do them. So this is equal to, now for me to use my fraction technique, right? I have a fraction technique which says that if I have 1 over a minus 1 over b, for me to multiply, I use first, second, and then third. Somebody is like, what are you trying to do? Okay, so when I say first, so you can see that the first line is this is the first line. So first, so it will be 1 times b, which will be b. Then I plug in any sign which is in the middle here, minus. Then second is this, so second will be this. So that one will be 1 times a, which is a, divided by, so the third is divided by, so we are going through this, divided by a times b, which is ab. This one, any fraction that you are going to use to work is going to work out. Any fraction. This one, like we can do that, but we need to always, when you are dealing with fraction, try and see if you can simplify first before you think about using that. So I think 9 can go to 36. I think 4, right? Because 9 times 9 is 18. Yeah. So relax. So 9 times 9 is 18, right? Then 9 times 9 is also 18. 18 plus 18 is 36. So this is, now we'll go to 9 goes to 36, 4. So this one is going to be minus 4, minus 4. Then 6 goes to 24. How many times? 6 times 6 is 12. 6 times 6 is 12. 12 plus 4 is 24. So 1, 2, 3, 4. So 6 also go there, 4. So minus 4, which is going to give us minus 8. Very simple, right? If not that, then what you can do is we can use the trick here. This multiply this first, this time this second, then you divide by this. But we were able to simplify it from there. So now we need big f of 5, big f of this one. So let's look for big f of 5. This one will be equal to 3, 5 squared minus 4, 5. plus 1. 3 times 5 squared is 25 minus 4, 5, 20 plus 1. Now 3 times 25, you're going to get 75. Then minus 20 plus 1 will be minus 19. Then now if I want to do subtraction, even if I subtract 5 from 7, that will be 6. Then 6, because this one is greater than this, it will reduce this one to 5. Then 15, then this one will be 56. Good. So that will be f of 5. Then I need f of minus 1. What is f of minus 1? 3 minus 1 squared minus 4 of minus 1 plus 1, right? So let me bring it down so that you're able to see what I'm doing. Then this is equal to 3 times 1, because minus 1 squared is 1 plus 4 plus 1. And this is going to be 3 plus 5, which is equal to 8. Is that right? Yes. So now what we need is we need f of 5 minus f of minus 1, which is f of 5 is 56 minus 8, and this is going to give us 48. So that will be the results for that one. Now let's look at this one. This one we need e of 100 or 100, which will be equal to 4 times 100 divided by 600 minus 2 times 100. And this is going to be 400 divided by 600 minus 200, which will be 400 divided by 400, which is equal to 1. All this thing we are going to get 1. Life is not fair. Okay, so now we have this function. We need f of 0, f of 1, f of minus 1. So let's do that. F of 0 will be equal to 2 times 0 to the power 3 minus 6 to the power 0. 6 in bracket 0 to the power 2 minus 1. So this one will be 0, this one will be 0. So we are going to have 0 minus 1, which is equal to minus 1. We need f of 1, just plug it in this. So 2 times 1 cubed minus 6 times 1 squared minus 1. This is going to be, this is going to be 2 times 1 minus 6 times 1 minus 1. So this is going to be 2 minus 6 minus 1. And this is going to be minus 5. F of minus 1 will be 2 times minus 1 cubed minus 6 minus 1 squared minus 1. And then this is going to be 2 times negative 1 to the power 3 is still negative 1 minus, this one will be minus 1. Then minus 2 minus 6 minus 1, which is going to be minus 9, which is very nice. So I think I'm done with the video. So the next video we are going to look at change rule, right? And then we will look at how we can also go through, when the function is of this form, like this, and different forms, right? Where we cannot use the power rule to do that, right? We can actually use the product rule too as well, but we need to use the change rule to also do the process. Right, so see you in the next video.